What is the major product of this reaction? And what we have here is a conjugated triene. That's 1 single bond, 2 single bond, 3 pi bonds, all conjugated in a ring structure. And we're using Br2 and 60 degrees, which is above 25 room temperature, and therefore we're looking for the thermodynamic or more stable product. So let's go ahead and take a look at two possibilities here. One possibility is that the bromine will attack in this position. The other is that the bromine will attack in this position. Remember that the electrophilic attack will always be on the ends of the conjugated system, never in the middle, because that would destroy conjugation and create a less stable intermediate. So what I'm doing now is I'm drawing a possibility where the bromine attacks from the top, and then I'm creating all of the different locations where we have a carbocation. Now, if you look at this, you should be able to recognize that all of these are going to be secondary. This represents the hybrid, and it isn't necessary to draw out all the resonance forms. You can simply draw out the hybrid if you know how. If not, drawing them all out is fine, and I've shown you how to do that in a number of previous videos if you're watching these in order. Okay, now let's take a look at the other possibility. In this case, the bromine would be attacking from this lower right side, and we would get positive charges like so. And what's important to understand here is that in this case what we have is we have a tertiary carbocation right over here. And that is going to make the pathway on the bottom way more likely to occur. So that's what we're going to use to determine the final product. Now you also should notice is that what happens when we do this is that when this bond that you see right over here swings out, it forms a positive charge adjacent to the bromine, and then that positive charge will jump over a carbon and then jump over a carbon. You see the same thing here. Attacks the bromine, you get the positive charge right next to the bromine. Here, jumps over a carbon like that, and then jumps over a carbon like that. Okay, so that's how that works. Alright, let's go ahead and see what we get now. So what I'm doing is I'm using the attack that we said was preferred and going ahead and drawing out all the resonance forms. Now, if you were not sure how I did the previous page as far as the locations of the positive charge, you now see the exact mechanism for how that's done, and so we have that right over here with the electron flow. And now what we're going to do is, remember it's Br2 we're adding, so we've added one bromine, and now we're going to add the second, the bromide, so we'll just add those on as you see below. And these will represent the only three compounds in consideration. So only these three. So let's take a look now at the answer key, and let's also take a look at the molecules that we just created. Now what I've done over here is I've gone ahead and I've indicated that this was a 1,2 attack, this was a 1,4 attack, and this over here is a 1,6, 1 here, and then you number around this way. Okay, 1,6. She didn't ask for that information, but she could, so that's how it works. Now let's go ahead and identify the relationship between these molecules and the choices on the answer key. So what happens is the 1,4 is C, and the 1,2 is B, and the 1,6 is going to be A. So all of those are in consideration, and answer choice D is not, because it was not given in the choices that we have created right over here. Now we can eliminate C here, that's the 1,4 attack in this case, because this isn't conjugated. We're looking for the thermodynamically more stable product, and therefore this being non-conjugated would certainly not be the answer, so C is out. And then between A and B, the only real difference is the locations of the bromine. And this makes it kind of tough because what we have here is we've got a conjugated system with a methyl group attached, pretty much the same structure. And the question is, does the bromine help or hurt the stability of the molecule? Now you could argue that the lone pairs on the bromine are going to help that bromine become part of the conjugated system, and the more conjugated system is going to be more stable. Or you could argue that the bromine over here has an inductive influence which removes electron density from the conjugated system, destabilizing it and making it less stable. Now I happen to know the answer is that the inductive influence of the bromine is going to make answer choice B less stable, and therefore answer A is correct because the bromines are not directly bonded to the conjugated system. I'm not certain how you're supposed to know that, but I do know that the answer is A, and that's how you work it out. That's a wrap.